All right, this is it. January 2023. Maths paper. So I'm going to do the paper from this year. Yes, this is the actual paper. I'm going to do the solutions for the paper, that is. I'm going to do the first section. I just finished my Form 4 maths class. And these days I just happen to be so busy, but so busy. So I'm a little tired, and it can be a little problematic to do maths when you're exhausted, when you're completely exhausted. You might make mistakes in the arithmetic. I mightn't be that quick, but I still want to run through the questions as fast as I can. I hope to finish within the hour, so we can get on to things. So you're all going to see the solutions, and you're going to see most of the questions I didn't come to. I did one or two with Miss Nalini just for racing, for fun in the students. What else I can say? So y'all, can you take a screenshot of this and post it on WhatsApp for me? Or maybe I'll post it on my Instagram, WhatsApp, anything you want to post it on, so that we can let people know that, hey, it's hitting them, the solutions here. It's one thing when you're going to take a picture and then boom, you see the selfie camera, and you're like, not that. So let's go, bang. Doing the live solutions now. So you'll press like on the video, subscribe, interact, type something, say, hey, what is you seeing? Let YouTube know the video is a real live video, and they will send some more things there. Doing the maths paper now. So we're about to get into the solutions. As usual, if you see any problems, if I encounter any problems. So the last few years, I find I'm doing really good. Like I'm making any mistakes. But if I do make any mistakes, I'll just put it in the comments. I don't think I should make any mistakes. But if I make any mistakes, forget anything, mistake anything, I'll put it in the comments. So you could always look in the comments to see if you see a question looking kind of fishy, like I did something, right? Let's just do a couple shout outs. Hello to Undercover Tarzan Video Academy, Gia. Hopefully paper one is easier, says Siobhan. Sarah says she'll be finding paper was good. I heard it was the best paper 3 ever. Paper 3, but this is paper 2 I'm about to do. Alex said the test was hard. How you all find it was? Makisha says hi. Renee says she may have to go back in May. Blessings, Rachel. Blessings. And all good for you, Rachels. And I think I know this Rachel too. Bless her. All right, the screen not clear. If the screen not clear, it's very simple. You use the gearbox icon and you raise the resolution. You raise the resolution. So the gearbox item, and you raise the resolution. So if anybody come in and say the screen not clear, let them know what to do, right? So this is just a calculator. It didn't say by using a calculator. By rounding each number in the expression below to one significant figure, estimate the value of so rounding. So let's round it out. The square root of 108 is 9. 19.7 to one significant figure is 20. 5.29 to one significant figure is 5. So this is approximately 9 over 25. Right? Estimate the value. 9 over 25 is an answer. So they should give you a full answer for this. This is an answer. I can't really simplify. So 9 over 25 is the answer here. Everything was approximated to one significant figure. Find the exact value of this. Give your answer as a mixed number in its simplest form. So this is a division sign. 9 over 25. You all should be able to see. If it's blurry, you all could just let the people who say what to do if it's blurry. I just raise the resolution. This person is saying it's blurry. Raise the resolution. That's not be going into full speed. 9 over 25 is the same as if you multiply that by 100 over 1, and somebody say 5.8. What is this? Is this 0.36? Yeah. 0.36, right? So 0.36 as a math teacher, I would give that as well. Also an answer here. Find the exact value of 3 and 3/8. Just want to make sure round to one significant figure. Yes. 3 and 3/8. 3 by, let me just pin Alana's comment for a second. 3 and 3/8 is the same as 3 by 8 is 24 plus 3, 27 over 8 divided by 5/12. And I'll just put 4 over 12 as well because that's the same as 1/3. So this is 27 over 8 divided by 9 over 12. So you can look up on my channel for the Casio calculator. I did a few videos on that, and that's like one of the best calculators to buy. And we divide it. So this is the working for part 2. This is the working for part 2. 27 over 8 multiplied by 12 over 9. And 9 can go into this 3 times. 8 can go, 4 can go into this 2 times. So I'm getting 9 over 2. Given your answer as a mixed number. So as a mixed number, what are we getting as a mixed number? So I'm getting 4.5. Why is any chat if you all agree with that? Why is any chat if you all agree with that? Lovely. Part B. Due to the COVID-19, and if anybody from my class, you all could just share the link with the class. Due to the COVID-19 pandemic, the number of available seats in a hall was reduced from 125 to 93. Calculate the percentage decrease. So the decrease as a percentage, 125 minus 93 all over 125 multiplied by 100 over 1. And you can put in that into your calculator. Whole. So 125 minus 93 all over 125. What percentage you all get? Feel free to put the answers now. We have 100 of you all here. Multiply. Don't forget to press like on the video, folks. By 100 over 1. 25.6%. 25.6%. So let me just make sure I answer the correct thing. The number of available seats was reduced. Calculate the percentage decrease in the number of available seats, right? So there wasn't any tricks here, right? So okay. Mika, no Blake, there will be a new exam. Mika invests a certain amount of money in a bank that pays compound interest at a rate of 2.5%. At the end of 2 years, the value of our investment is calculated the amount Mika invests, and a formula was given. And they want the investment, so they want P. P is the principal of the original value. That's how much Mika invested, and they give us the amount. So we either being asked to backwork this, or what you can do, or there's another formula that we can use, right? But because the formula is given, let's backwork it. So A is equal to P by 1 plus R over 100. And this formula is a simplified version that they use for CXC. This is not for Standard 5, this is for CSEC students. And P is what we are trying to find. The amount was given 7564. P is what we are trying to find. 1 plus R, R is 2.5 over 100. So 1 plus 2.5 over 100 is 102. Or 102.5 over 100. Or we could write it like 1. Let's put the substitution line. I don't trade that. So we'll put 2.5 over 100, and then we put the squared here. So the next line, what we could do in the next line, we could bring across the P, we could bring across this. We could work out this as a whole and bring it across. So this is 7564 is equal to this number to be squared. So you can do it in your calculator. This number is the same as 1.025 to be squared. 1.025 to be squared is how much, folks? 1.025 to be squared. Hello, everyone. Is that number there. And I'll leave it in the exact form. Right, so 1 plus 2.5 over 100, 2.5 over 100, so that's 100 and 2.5 divided, so 1.025. And we square it up and we get this number. So 7564 is equal to P, and the number we had was 1681 over 1600. So if I bring this across, it'll do a little flippy dips. Therefore, P is equal to 7564. Now, this could be a number that you'll get. Multiply by 1600 over 1681. I could say 7564 divided by answer. That gives me the same thing. P is 7199.5. Calculate the amount she invests. All right, well, let's give it to the cents. 2. So that's the number I'm getting there. You leaving the video up? Yeah, leave the video up. So let's just double check it now. At the end of 2 years, did I do the correct thing? I'm trying to find the principal. Yes, the amount she invested, which is P. And the amount was given, the value of investment was this, 2.5% per annum at the end of 2 years. So 2 years went there. So everything looks all right. I can take this number and put it back in there and see if I get this. And the number makes sense, about 7,200, 2.5% every year, 7,500. Yeah, so it makes sense. So I feel a little confident about that. Let's move forward. I can always double check it when I'm finished the exam. So this is simply a power to a power means multiply. So this is x to the power of 6, 1 mark. And when you divide powers, this is since any number to a power is x equal a by b, right? Power to a power, the power law, as some call it. This one is what we call the quotient law in indices. When you divide and you subtract powers. So this is y is equal to 8 minus -5. In the end, this is y is equal to 8 plus 5, which is y is equal to 15. And this is since when you're dividing and you have the same base, you subtract. Right? So clear we can show there factorize. This is not difference of 2 squares, this is just basic factorization. We good to go with that. This one is difference of 2 squares, so we want x minus y. I want x plus y. So we've got some very easy algebra here. What do you think about the algebra? For easy maths. Easy maths here. Hence, simplify the expression. So hence means use the information that we had above. So this is the numerator, and this is the denominator of part 2. So instead of writing the numerator and the denominator like this, I can use this and this. That's what they're telling me to do. So this is equal to y by x minus y, and x minus y by x plus y. So we have a kind of product stuff going on here, so we could cancel. That's fair. That's fair. And in the end, we end up with y over x plus y. So I personally, I find this question is incredibly easy. Hence, simplify. All right, so I already did this question. And the diagram below shows 2 rectangles, M and N, with their dimensions expressed in the terms of, yeah, Nisha, easy end, yeah. With their dimensions expressed in terms of x. Given the difference between the areas is, so we have a difference between the areas, and we want to show this expression for 4 marks. They're being generous with the marks. They're being generous with the marks here. What you all think? And they're saying show that questions have the added benefit of us seeing the answer. We have the added benefit of seeing the answer and show that questions. What just happened there? So the area is going to be x area of M. Let's do it a little structured. area of M is going to be, right now my undo key is not working. Area of M is going to be x minus 3 by 3x plus 4. And I can simplify this one time, but I don't really want to right now. And the area of N is going to be x minus 3 by x plus 2. Both of them have x minus 3 involved. So the area of M minus area of, we don't know which one is the bigger one. Which one is the bigger one? This is 3 times x plus 4. This is x plus 2. So this is bigger, 3 times x plus 4. So M is the bigger one. So just making sure that M is the bigger one. Area of N should be 64. So I have x minus 3 by 3x plus 4 minus x minus 3 by x plus 2 must all be equal to 64. So it feels like I can just factorize all this before I do anything and put 3x plus 4 and then put minus x plus 2. And work it out like this first. Yeah, maybe. With a show that question, so if I make a mistake, I can see the mistake. So I factorized out the common x minus 3. No, you can work it out the long way, but I'm just being a little extra here. X minus 3 by 3x plus 4 minus x minus 2 is equal to 64. So we have x minus 3 by 2x minus 2 is equal to 64. Let's work this out. So this is 2x squared. I'm multiplying. 2x squared minus 2x minus 6x plus 6 is equal to 64. So this is 2x squared minus 8x plus 6 is equal to 64. Let me see if we're in the path of righteousness here after all of this. If I divide everything by 2, what is going to happen? Did I do anything wrong? I think I'm good. X minus 3 by 3x plus 4, x minus 3 by x plus 2, x minus 3 by 3x plus 4, 3x plus 4, x plus 2. Yes. And 3x minus and minus. So we have plus. This was plus 2. That's that mistake there. So I would have plus 2x here. Yeah, so this should just be 4. Everything else looking good? No, this is not looking good. So this is negative. All right, and then I bring across the 64, which is negative 64. Let's see if this is anything like what we're supposed to have here. I'm seeing 2x squared minus 4x minus 70 is equal to 0. If I divide everything by 2, I get x squared minus 2x minus 35 is equal to 0. And this is what I think we were asked to prove that. Yes. X squared minus 2x minus 35 equals to 0. So this part here made up for it. For the question being easy, but in that you had a lot of work to do. But it was still easy. And number 2 was kind of the easier side of what we normally get for algebra. Let's see if it gets harder. The following diagram shows 3 quadrilaterals. P, Q, and R on a square grid. Q and R are the images of P after it underwent. Who's the images? Q and R. Q and R after it underwent 2 transformations. This is the original and these 2, right? So on the grid on page 9, draw the image of quadrilateral P after the translation vector 10, negative 4. Label this as P prime. Excuse me, here Javish, 10, negative 4 for P, So we're going to slide it 10 and drop it 4. Slide it 10, so we're on 7. So we should end up on 3 over here. We slide it 10 and then drop it. How much? 4? 1, 2, 3, 4. So we did. Let me just make sure it's 4 we're dropping it. So we go in 10 to the right and we drop in 4 down. All right. And we should expect something like this. 4. We'll obviously using a ruler, P prime. Reflection in the line y is equal to 0, label this. The line y is equal to 0 is the x-axis. Y equal to 0 mean x-axis. Label this P double prime. So if you're reflecting 1, 2, 3, 4, it should go 1, 2, 3, 4 down. First point is over here, negative 4. And then we expect the other 2 points to be there. Right there. So zoop, 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 zoop. Of course, make sure your line's looking respectable. Thing like you could show your parents something. P double prime. And that's some marks there so far. So reflection in the line y is equal to 0. This is the line y is equal to 0. The x-axis is the line y equal to 0, people. Describe fully a single transformation that maps quadrilateral P onto quadrilateral Q. So you want to say how P get to Q. It's clearly an enlargement. And to find the center of enlargement, we'll connect the points and extrapolate. So out pops the ruler. Okay, let's connect these. Let's connect these 2 points here. All right. So it seems like the center of enlargement might be somewhere off, boy. Let's connect these 2 here. Oh, no, it's right there. It's right there. It's right there. Both of them are the same. There we go. So we connected the 2 points. And if we connect the 3rd point, we'll also see that it runs into there. So it's here. The center of enlargement is negative 10. And you should use dotted lines. Negative 10, 7. So it's an enlargement. But what is the scale factor? Well, this is 2. And this is 2, 4, 6. So it's a scale factor of 3. And you can also see it here. So if you want to describe this fully, you need to say enlargement. You must say that word. If you just write enlargement, you will get 1 out of the 3 marks. You must say scale factor of 3. And you must say the center of enlargement is, well, we got negative 10, 7, negative 10, 7. And quadrilateral R, how we get to R, boy? R looking a little fishy. It's clearly some form of rotation. But how do we get the center of rotation? So the calculations we get in the center of rotation is a little sketchy. Let's remove all the unnecessary lines. This graph going and get real tack up, boy. Center of enlargement. One of the ways we usually get the center of enlargement is connect the points and bisect. But I don't have a good object for bisecting here. So I will be doing a little bit of guesswork. That. Would it be this one? 2 down, so across. 2 down, 1, 2, 3, 4. 2 down, 1, 2, 3, 4. Yeah, so it's gonna be here. It's gonna be here. So the working that you're supposed to do to get the center of enlargement is that you connect the lines and then you bisect the line. You bisect the line like this. So you have this line going here. Then so you notice we connect the points, right? The relevant points. And you connect this point to that point. And you bisect the line again. And they would both intersect at this point. How did I work it out in my mind? I'm seeing like this is doing 2 here, 4 here. And this one is doing 2 here, 4 here. You understand? So it's like this L became sideways like that. So that's how I worked it out in my mind. So the solutions will be up on my website soon. So you'll get to see the actual construction lines for how we get this point. But for now, suffice it to say that's the center of enlargement there. And of course, it went from on this side to that side. So you could see anti-clockwise 90 degrees or clockwise 270 degrees would work as well. So once again, you need to say rotation about the center of rotation was -42. And it's 90 degrees anti-clockwise. Or you could have thrown in the anti-clockwise word here. Anti-clockwise rotation about a 90 degrees anti-clockwise rotation about center 42. Right? Or you could say a clockwise rotation of 270 degrees. There. Let me just make sure. Point here came to there, into there. Yes. So if I made a mistake, I'll double check it, but I think that's where it should be. This join up split will go there. This join up split will go there. Yeah, I think I'm good. What about you? Yeah, I think that's the center of rotation. Yeah, we thinking we good here. We feeling like we cooking it Ramco gas. How many of you all got out that one? And that's it. That's 9 marks. 6 and 3, 9. Write down the coordinates of the x-intercept of the line L. Coordinates of the intercept of the line L. X-intercept is 6, 0. Anymore? I find it giving you some easy. They're doing the mix is pretty decent because there's some easy questions and then there's some tough questions. So the mix is decent. So you can make it, you can live. And the y-intercept of the line M is 0, -2, right? And the equation of the line L is, and it actually gave you the equation. How kind of them? Find the value of K, given that 9K lies on the line L. Now they ask you to find it, not use the graph. Because I mean, you could substitute 9 and see that K is -1.5, but they want us to find it. They give us the equation of the line. So if you have x plus 2y minus 6 is equal to 0, substitute x being 9, we get 9 plus 2y minus 6 is equal to 0. Bring across them numbers, you get 2y is equal to -3 and y is equal to -3 over 2, which is -1.5. When I bring across the 9 and the 6 now, the 9 would be negative and the 6 would be positive, so you'll end up with -3. Find the equation of line M in the format y is equal to mx plus c. Fine. Well, we know a point on this line. We also know another point on the line. M is 2, 2. So we can find the gradient, and then once we find the gradient, we know where C is, so we can just find it. So let's find the gradient of M. Gradient of M. And the equation for gradient is y2 minus y1 over x2 minus x1. So this is 2 minus -2 over 2 minus 0. So I expect 4 over 2. Gradient is 2, which I expected because it's going up 2 for every one it goes across. And therefore, equation of the line is y is equal to 2 is the gradient x and -2 is the y-intercept, where m is equal to 2 and c is equal to -2. Y-intercept gradient. So far, so good. So far, so good. Show by calculation that the line L and M are perpendicular. Well, we can rearrange this. And rearranging the equation of line L, this is the equation of line L, we will get what we get by, I believe we'll get y is equal to -1/2 x plus 6. You could check, you could double check it. I'm speeding. I'm going a little fast. Remember, this is the solutions. So you bring across the 6, you bring across the x, then you bring across the 2, and you would see that you get this. So therefore, gradient is a half, negative a half. And since the gradients are in this relationship, you could call this M1, or you could use the same L, ML. ML and M2 are related by this negative reciprocal, we call it. They are perpendicular. For gradients to be perpendicular, they need to be related by that. So if you notice, this is negative a half, flip this, you'll get 2 and switch the sign. All right. Now, you can go and watch my videos on coordinate geometry for the theory and a slower breakdown of what is happening here. This is new to you. Using L and M, represent the graph of a pair of simultaneous equations. Oh, so line L and M represents some, so it's a graphical solution to simultaneous equations. The solution set will be 2, 2, where they intersect. Both of them intersect at that point, 2, 2. And you can write point of intersection. And you move on. And another thing I noticed about this paper, it's moving at a faster pace for me than last year's paper. Moving at a faster pace. Here's a cumulative frequency question. Nice curve. Using the cumulative frequency, find and I was doing this recently. I think I was doing this recently on the channel. I definitely did this in the crash course. A good bit of this stuff in the crash course come here, boy. Y'all, join my main crash course. Number of students who took more than 15 minutes to solve the problem. So this is how much time they take. If I go here to 50, and they want to see these dotted lines, if I go here to 50, I'm seeing, now these, I'm not too sure how the diagram was drawn in the exam. I'm just using my diagram here, hoping that my diagram is really done really well. So this is 188. 188. So therefore, more than 50 is 200 minus 188 equal 2 students. There are only 2 students above 50. Is it 186? Let me just make sure I'm doing this correct. Oh my gosh, nice. 196. And I say 200 minus 188 is 2. All you are tired. Spare me. Spare me. This is 196 because this is 180. And it's going up in 4s. 84, 88, 92, 96. I hope I didn't make no arithmetic mistake from before, because like right now my brain is shut. So 200 minus 196 is 4 students. 4 students. Alana, you're the path of righteousness. The median time taken to solve, so the median is middle. We're basically looking at the 200 plus 1 divided by 2 term, which is approximately 100.5. So approximately 100. So we're going to look at 100, 100.5, bring it across, just a smudge above 100. So that this would work. Bring him down. Let's make sure I get the scale correct. Yes, so this is going up. So this is 33. So 33, and let's see, median middle time is 33 minutes. So median is middle. Probability that a student chosen at random took at most 28 minutes to solve. So let's find where 28 minutes is. So a lot of this 28 minutes is here, strikes there, comes across at 60, I'm going to say 61, 64. So 64 students took 28 minutes. So what's the probability took at most 28 minutes? Well, under 28 minutes, they mean. So all those who took under 28 minutes, and there was how much I said just now? Oh, I forget the number. Normally these things will happen. So 64 out of 200 is the probability. Technically, this is the answer by itself here, but I could break this down. I can break this down. Right? 4 could go into this how much times? 13. Am I talking sense? 16. I lose in my mind. 16 times, and 4 could go into this 50 times. Excuse me. And 2 can go into this 8 times. 2 can go into this 25 times. 8 over 25 is the probability. Or you can express this as a percentage or whatever. Using the combinatorial frequency curve, complete the table. I did this exact question. Anybody here for my crash course? I did this exact question in the crash course. Very, very similar to Nalini. They question here, you know. They teach we question now. So what are we doing? Frequency. You just need to read off these frequencies: 15.5, 45.5. This is midpoints of the time. So 15.5. Yeah, well, a little sleepy too, boy. 15.5 is here. And let's say that is 22 minutes. Getting 22. And 45.5. I hope I speeding. I hope I behaving myself here in the streets. 45 is 184. 184 minutes. And then they just sit in them a little multipliers. So multiply across. Wait, now that is all. Oh no, they want you to calculate the mean for sure. The average, the mean. So you need to add up this, right? The sum of the fx. But let me finish the table first. 3 marks to complete this. They put the marks better. CXE, so far, are they improving and how are they doing that? Whoever do this paper need to, if you're watching this, teachers who come together here do a good job. I must say, I'm feeling a sense of fairness in the marks and everything now. 341. You all are just doing a little multipliers here. Oof, I got a big number here, but 8,372. All right, we gotta take it. So we finished this, the chart. The mean is always the sum of fx over the sum of f. I don't know why I put f of x. It's just fx. So I can put the sum of fx. All right, this has nothing to do with functions. So we add up all of this, adding it up on my phone, right? The weird calculations I'll do on the screen, but for now I just want to finish it really fast. 66 plus 341 plus, you all can do it in the background, 1071 plus 2982 plus 8372 plus 222. So I'm getting this number 13054, and I hope that is the right thing. And then we know the sum of f is 200, right? If you add up all of this, you should get 200. Wait. So then I have a big mistake here. Let's see the mistake I had here, boy. I need a little subtraction. I forget to subtract. So this is 22 minus the 12. I need to subtract the things from before. Yeah, 41 to 50 wrong. So this is 22 minus the 12. So this is actually 10. This is the number of items between 11 and 20. So this is 184 minus all of these. So big mistakes. That number not supposed to be that big. Clearly. The number is go up to a peak and then come back down. So that's a red flag. So 184 minus 884 plus 42 plus 10 plus 12 184 minus 148. Well, I'm getting 36 here. So I hope that is obeying the law. I would be able to probably tell if I'm looking obedient to the law. 1638, looking all right. Yeah, 1638. So, yeah, so the idea was they want the number, the frequency between 11 and 20, between 21 and 30. So all I got 22 here. That was the number from 15.5 I needed to subtract. So let me just double check and make sure everything adds up to 200. That will tell me if my readings was good. 12 plus 10 plus 42 plus 84 plus 36 plus 4. 188. So I may be a little off somewhere. Maybe I was off on the first one. Because I kind of averaged the first one as 22. It probably was 24. Now, I wouldn't be 100% sure on these numbers. The reason I wouldn't be 100% sure on these numbers, I don't have the exact graph that you all got. So, when the solutions is done, when we finish the solutions and put it on my website, you would be able to verify if it's 12 here or if it's 38 here. But most likely, it's probably was 12 there to make this proper. All right, so let's just double check these numbers here because I'm losing marks right now, but let me get back their marks. 12 times 15.5, 186, and 45.5 times 36, 1638. All right, and now we could add it up and divide by 200. So we have 66 plus 186 plus 1071 plus 2982 plus 1638 plus 222. And this is what I'm getting. I'm getting 6165 divided by 200. I'm getting 30.825. So approximately 31 minutes. So let me see if that's sounding good. 31 minutes as the average. Yeah. The median is 33. So it's a little lower than the median because more of the graph is on the lower side. It's skewed this way. So yeah, the number looking good. But this is one I definitely need to double check with the actual diagram. Right? So if your number is slightly different than mine, don't frighten. Actually feeling pretty good about that number. 30.1 to 31. All right. This question was pretty rough. It started off simple, but the last one was a little scene. Hi Marissa, what's up? So show that the total length of the running track. So the total length, I did this question and I'll post it on TikTok. The total length will be 98 plus 98 plus the length of a whole circle, which is 2 pi r. So it will be 196 plus 2. They said to use 22/7 for that. And r is not 49, but don't forget r should be 49/2, right? And then here you take it. When you put this in your calculator, this should boil down to be 350. If it doesn't, you know you made a mistake. So that's the length around the track. That's what the question was saying. You can read it up. Nathan is walking at a constant rate. Find out his time. Well, speed is distance over time. So time is distance over speed. So simply put, all you need to do is put the distance, which is 350, not just 350, 7 laps. 350 times 7 laps over 1.4, and you would get your answer, which is what? Hi, Tamara. So we have 350 multiplied by 7 divided by 1.4. 1750 is what you should have gotten for that one. So the first few questions were simple, 2 marks, 1 mark. Tafari runs 1 lap of the track. Can I finish? Just over an hour. Tafari runs 1 lap of the track in 68 seconds, determine the number of laps the Ferrari completed in 1 hour, running at the same speed. In 1 hour, how much seconds we have by? We have 60 minutes times 60 seconds. So we have 3600 seconds. And if he's taking 68 seconds per lap, so number of laps would be 3600 divided by 68. And how much is that? Divided by 68. So what I will do is I'll do each question part by part and break it down. I'm getting 52.9. This is bad because that's a decimal. But complete, he can complete, so I'll say he completes 52 laps. I'd want to check over this one. 60, the fact that I got a decimal. Well, I feel maybe that's what I wanted you to do. Get the decimal and then say he completes 52. Yes, so we are the student hub has lots of students from outside of Trinidad. So Guyana, Barbados, St. Lucia, St. Vincent, Jamaica. Yes, you can do lessons even in the United States. It's online, so you can do it. Hold up. Double checking everything here. Total length, we add up 98, 98, and one semicircle and one semicircle make one whole circle. So we got that. Distance over speed will give us time. This is the total distance. He walked 7 laps, so it's 7 times the 350. Yes, good. 1 hour, 68. Yeah, so this was the tricky part that I noticed in this question here. And one person, they introduce another person, Nathan. Nathan is running 1 lap every 72 seconds. Tafara is running 68 seconds. And they want to know when they will coincide again. So meaning both of them took off on this point L. And they want to know how many laps will make them coincide again back on that point L. If one is moving at 68 seconds per lap and 72 seconds per lap. What I want to say is there is one way to do these questions. When you see this, when will they coincide? That's a clue. When will the points be at the same time? When it will happen again? That's a LCM question. It's one of the most sly or subtle or hard to pinpoint what it is they're talking about questions in the entire CSEC maths. Top students and things be trying to figure out what to do in this question. It's an LCM question. They brought one with the planes landing every so much minutes. When will be the next time 2 planes land at the same time? That's it. Yeah, so somebody actually alternate methods to do online payments for classes for the student hub. Some people do wire transfers, but wire transfers are expensive. So if you could do PayPal or credit card payments, you would have less expense. So you'll be paying close to the actual price per class, which is about 300 TT per month. All right, so calculate the least number of laps. Let's do the LCM. So LCM question 72, 68. You all remember we break down LCM? So you can do prime factorization, but I'm just going to do some educated shortcuts here. Maybe I can divide by Maybe I can divide by 4. Yeah, I'll get 18 and I will get 17. Then I can divide off that 17 clean as a prime number. And I can divide 18 one time because it's just 18 alone to break down. There's no common factors, and that's the only thing I have to watch out for if there's common factors. So I can just divide by 18 here and break it down. So that's the fastest way I can do a prime factorization here. The reason I choose 4 here because I needed to get the common factors out. 4 is a common factor. And both of them divided by 4. Or if you're afraid of doing the shortcut, you just do prime factorization. So you divide by 2, 2 again, then 9, then 17. Anyhow, what you're supposed to do after this is multiply up these numbers. And 4 by 17 by 18 is what, boy? 4 times 17 times 18 is 1224 seconds. That is when they will coincide again. 1224 seconds, which is pretty short, but it's short because there's a nice big common factor of 4 that makes it not have to multiply too big. Actually, there's common factor of 8. No, 4. Okay, so that's what we're looking at, 1224 seconds. If you're seeing blurry, you just need to raise the resolution. Somebody can write that. If you're seeing blurry, you just need to raise the resolution. By the way, this is not for SEA, this is for CXC, big difference. So that's not the answer. Both of them will bounce up again at 1224 seconds. So it means Nathan would coincide at 1224 divided by 72, which is Tafari completes number of laps. 1224 divided by 72. Nathan completes 17 laps, sorry. Only I'm tired, saying weird things. But I'm feeling like I'm still on point yet. Tafari completes 1224 divided by, they're going at 68 if I remember correctly. 1224 divided by 68, 18 laps. That's how you do this question. I would say this was the toughest question we come across so far for 3 marks. And they didn't kill you off. They didn't pay for 4 marks. Or they didn't make this the whole question about this. So not a bad approach to how they structure this. Somebody say I should have go live before the exam. Thanks, Marissa. I'll pin what you're right there. How are you doing that, boy? Are you really trying to see my downfall here, boy? The grid below shows the first figure in a sequence. So those are all interested in the classes. I've seen a couple of people talking about it. It's +1868. That's the Trinidad area code. 4724221. WhatsApp that number and sign up. Or you could follow me on Instagram and you'll see me posting regularly when it's sign-up season in the Student Hub. We have all the popular CXC and CSEC and CAPE classes, right? All right. So the grid below shows first 3, or we need to figure out this. The next sequence is the sequence question, is number 7. So this is the last question I'm doing for today. I'll do the section 2, hopefully tomorrow, please God, or Saturday, or I'll do the section 2 subsequently. So this is easy. Seems like they're shading up and keeping the top shaded. How much we reach now? 1, 2, 3, 4, 5, 6. 6 now. 6 now. So let's rate them as 6. 2, 3, 4, 5, 6. So all the X's should be shaded, and all the rest should just be highlighted now. So the best way is to draw all the lines. You come and you darken all the lines that I have in purple here. That's all. And I like this method that they use. Whoever do this paper thoughtful, but you come up with some nice ideas and testing the student without like killing the student. And then there are some really tough questions, so they could still get nice differentiation in the marks. Nice. I like this paper. I like this. I need to ask more teachers about what they think about this paper. I like this paper. So we have 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, and we're going up 1, 2, 3, 4, 5, 6. So we're looking good. We're looking good. PXL dumb. I see PXL dumb making a comment there, boy. PXL, what you're really trying to see, boy. And that's my partner too. So it have no there's no competition. In fact, I've seen him he was around even before me. So he's a veteran in the business. He was around before me. So I used to talk to him and think we still talk. We good. There's no start anything there, PXL man. You know from the This one, I know you. You come back making trouble, why? All right, so now we need to do this last bit. We need to do this last bit. We need to do this. I know you. I know you. If you feel I don't know who you is. 1, 2, 3, 11. All right, so this is the popular thing. And what I tell you all to do is in this table, this is the last question for today, is let me just remove Marissa question. I'll see what to do, right? What we need to do is always try to finish out the last line first. So see if you can figure out what's going on in the last line. Like get the end term here. Now, keep in mind, I'm just doing the solutions. This would make the most sense to students who are at about 70% and above. If you under 70%, some of this will just go way over your head. But you could always go and review the specific topics. This topic is series and sequences. So you're always trying to do the last line here first. So 5, 7, it started at 5. It seems like I'm multiplying by 5. So 2 by 5. No, I'm multiplying by 2 because it's going up by 2. So I'm multiplying by 2. So it's 2n. And how do I get it to make 5? I'll need to add 3. So this is 2n plus 3. Let's verify. When n is 2, put 2 in there. 2 by 2 is 4 plus 3 is 7. When n is 3, put 3 in there. 2 3s are 6 plus 3 is 9. So it works. That's the formula there. 2n plus 3. And the perimeter, perimeter. What is the perimeter doing? Can we relate the perimeter to the figure number as well? Can we relate the perimeter to the figure number? 12, 6. It's going up by 4. So it's just 4n. And I would need to add 8. So 4 2s are 8 and 8 is 16. 4 3s are 12 and 8 is 20. So it works. So we get in there, And the total number of squares is always n. It always seems to be n plus 2 to be squared. And that's it. That's all we can really write there. It's n plus 2 to be squared. We can't put the answer, because we don't know what the answer is, right? Is equal to whatever. So it's always n plus 2 to be squared is the total number of squares. Figure 1 is 3 squared. 3 squared. Figure 1 is, yes. So that makes perfect sense. N plus 2 to be squared. So now we can figure out everything else once we have this. Always do this line first once it's there. Even sometimes if they don't put it, you still want to do this line first. So 11, the line with 11, it's 2n plus 3. So 2 by 11 is 22 plus 3 is 25 we're looking at here. N plus 2 to be squared, so 11. We see what happens. N plus 2, I'm just watching the comment here. N plus 2 to be squared is 13 squared, so 169. So 169. What's going on here? Well, this is a big clue because this is always n, so I could just put 23 there. And this one is 4 by 23 plus 8. 4 by 23 is how much? Is it 92? 92 plus 8, this is 100. Yeah. 25, 25, 25, 25. Yeah, 100. Yeah, so this is 100. 25 squared is, yes, so that makes sense. So, okay, and the last part, what we're going to do today is how many white squares in figure 11. And that's simple because you have the number of colored squares here and you have the total number of squares there. So it's just a matter of subtracting. Notice how all of these are square numbers because they are areas, right? And all of these numbers are divisible by 4 because that's perimeter. And if you divide it by 4, you will get the length of one side. This is not the length of one side, this is the figure number, but the length of one side is 1 plus 2, which is 3, or 11 plus 2, which is 13. 13 squared make 169. So this question was on the easier end of series and sequences because there are so many ways to double check. How many white squares in figure 11? Yeah, so we want to substitute 169 minus 25, and we will get 4 for 144 white squares. How does that look? How you usually do in the first 7 questions in the paper. 18 marks off. The first 7 questions in the paper is worth 9, 9, 9, 9, 9, 9, 10 marks. So add that up and see how much you get. 1, 2, 3, 4, 5, 6. 54 plus 10, 64 marks. The next set of questions will be 12, 12, 12 marks each to add up to be 36 to make 100. So the next 36 marks I'll do at the next time. You can watch over this video. I'll leave it there. Keep in mind, if I made a mistake, check in the comments. I will have the mistake fixed there. I'm not saying like I make any mistakes. But you know, I'm tired now, boy. It could have something sneaking. So, which one is the most fishy one for me? Most fishy one is probably none. The toughest question I did so far here. This was probably the most fishy one. This had the most arithmetic. The toughest question I did so far was number 6, part B. That's where students will get the most amount of problems. All right, people, love and blessings. My wife calling me here and I don't want to have too much missed calls. All right, hold it on.